encounter in calculus, okay, arctangent. As we talked about earlier at the beginning of introducing arc functions, arc-trig functions, that we know tangent function is not one-to-one. And thus it does not have an inverse. Okay, so before we, and then of course, how do we make it have inverse? And we truncate, right? We truncate, just same technique we use for sine, cosine to produce arc sine and arc cosine. But tangent, okay, so before we do the truncation, we need to understand what is the domain, what's the range, what is the domain and what's the range. What are the details about this function, right? So that's to recall what is the domain, what's the range, and what's the graph, right? We did all of that in earlier sessions, maybe sometime last week. But you can look at those titles if you think you need to watch it again. Tangent function, right? So you can get the graph very easily. It's at your fingertips, But the question is how to read the graph, right? Identify the domain and range, identify some points on the graph. That is something we must get to. We must make sure we understand the graph. All right. So this is the tangent graph. This is a graph for tangent, right? We know that it goes in both directions indefinitely, right? Indefinitively in both directions. Now, what is the domain? And what is the range? We had extended discussions about the domain and range before, right? So now it's time that we're gonna review that to see for ourselves. You can see it's not a one-to-one. It doesn't pass the horizontal line test. Right? Yes? As you're thinking about the domain and range, all right? We look at these pieces, right? Obviously, tangent is the entire tangent curve is broken into pieces, slices, right? Slice 1, slice 2, slice 3, and there are infinite number of such slices. Each particular slice, actually, if you look at the slice right here, right? If you look at this slice, if you just look at this slice, right? Wait. Right? If you just look at this slice, if you look at this slice alone, it's one-to-one. If you look at this slice alone, it's one-to-one. And if you look at this slice, it's also one-to-one. So in order to create a function that's one-to-one, obviously we just have to pick one of these slices, even though we have an infinite number of slices, right? We have infinite number of slices. Which slice would be the simplest to pick? There are infinite many. Yeah, there are infinite many in that direction. There are infinite many in the other direction. Which one of these slices do you think it would be the simplest? The first mathematician who set up the, who worked on this, and the rule he set up since then has been, accepted by the scientific community throughout the world and beyond. Which slice do you think will be the most likely one to be chosen? Anybody want to comment? They all look alike, right? They all look alike. They all contain the information about range, right? So since you have no answer, let me tell you, this is the slice that's chosen. This slice is chosen. Okay, this is the slice that is chosen. And what happened to the rest of the slices, right? What happened to the rest of the slices? Now, before the slice, what is the domain? What is the range? What is the domain? What is the range? Let me see. Someone said something on chat. Wilbur said, from negative pi over 2 to pi over 2, range all real numbers. You said negative pi over 2 to pi over 2. You're talking about that slice, yes? Is that right, Wilbur? Just the middle slice. Very good. Very good. Just the middle slice. Okay. So now, if I'm not, so what is the domain of all the slices together? Okay, let's first review that part. What is the domain? Right, we have chosen, we have, marked the 3 slices, the many slices, right? There's some forbidden lines that the curve will never touch. And Wilbur's description about that tangent is correct, okay? So the slice we have chosen, okay, is between negative pi over 2 to pi over 2. You may want to notice that this is not exactly the same as what we did for sine. Okay, sine is less than or equal, less than or equal. Why negative pi over 2 are not included? So this interval, okay, between negative pi over 2 to pi over 2 does not include the endpoint. So it's exclusive. It's exclusive. Okay, so let's go back. This is the slice of our choice. But if we look at all the slices, what is the domain? How come I don't get answer for that? All right. Odd number multiples of pi over 2, right? The angle cannot be odd number multiples of pi over 2. So all real numbers, but odd number multiples of pi over 2. That's the domain. And the range, okay, and the range for both is between negative infinity to positive infinity. The picture shows that very clearly. The picture shows that very, very clearly. You can see from each one of the slices, right? Each one of the slices, right? Take this one, for example. The horizontal, okay, the horizontal span. This tells you the domain. What tells you the range? And this vertical span tells you the range. And in this case, it keeps going. It keeps going. We cannot contain that vertically. So the range is from negative infinity to positive infinity. Okay, and this is true for all the slices. This is true for all the slices. For that slice, okay, for that slice, the horizontal span is to be specified. And the vertical span is from negative infinity to positive infinity, okay? We cannot contain them. We cannot contain them. So in both directions, it extends indefinitely. And this is true for all the slices. This is true for all the slices. So as we have chosen the slice in the middle, when we need to identify how wide it goes and how high it goes. Do you guys follow me? So as we have chosen the slice in the middle, okay, it's easy to identify the vertical span, right? From negative infinity to positive infinity. In both directions, it goes in definitively. So the range for this slice, what is the range for the slice? The range for the slice is from negative infinity to the positive infinity. How about the horizontal span? This is why I'm asking you guys to identify the interval. Of course, I already give it to you. Do you guys see? Between negative pi over 2 to pi over 2. Okay, Wilbur has specified that also correctly on chat. Okay, so let's take this opportunity to review the situation here. Okay, Okay, only just review this piece. We know that there's a negative pi. So why negative pi over 2 to pi over 2 why negative pi over 2 itself cannot be in the domain? Because negative pi over 2 is not in the domain of the tangent as we know it. Okay. So now I want you guys to do one thing for me. Okay, I want you guys to do one thing for me. Okay, to see how much you understood. Okay, so what I'm going to do is that I'm going to draw these vertical asymptotes. Okay, I'm going to draw these vertical asymptotes. And you're going to identify some points and lines. Hold on. So that line, I meant it to be red and broken. Okay, I want you guys to identify these points. Identify, okay, I'll specify what I want you to identify. Okay, I want you guys to identify the line equation of the true red broken line. And I'm going to draw a few more for you to identify. At the same time, I'm also asking you guys to identify these 2 points on the red and the black. Okay, on the x-axis. So you know what you do, you know what you need to do, right? You need to identify these 2 points and these 2 vertical lines. So I'm going to draw a couple more vertical lines. Okay, you ready? So do that. Okay, we get these curves very easily. Okay, we get these curves very easily. At our fingertips, everybody has that calculator, right? Everybody has that calculator. Even if you don't have a calculator, you can find them. If you just Google tangent curve, you're gonna get a lot of those choices. Okay, they're gonna tell you. So in these days and time, the information, it's not hard to get those information. The question is, can you interpret the information, right? 2 more. So I'm gonna give you 2 more. Okay, hopefully this will wake up everybody. Okay, So the points you need to identify. Okay, the points you need to identify. Now, all these points at heart. With the heart. Okay, you need to identify the vertical line equation. The vertical line equation. Okay, let me mark them. Okay, let me mark them. So this line is A. That line is B. That line is C. D. E. F. Identify line equations. Identify the line equation of the vertical lines in red. Okay, and also identify the points at the red heart. Two things to do. So this is number one, number two. Everybody swing in action. Are you guys there?
Mm-hmm.
Do I get an answer for any one of these lines? At any one of the points? I'm using case sensitive. No answer, no answer. So I'm going to move forward. Okay, but I do want to give you some assessment at this point. Okay, I do want to give you some assessment at this point. If you find it difficult to identify the line and the points, that's elementary algebra stuff. That's elementary algebra stuff. Okay, or intermediate algebra, they cover those things. Okay, so when we talk about you're taking 5 courses in one, and these are the evidence you are doing 5 courses in one, and this part is about elementary algebra, intermediate algebra. So if you want to review this part, you may like to go back to pick up an elementary textbook, but it should be in any elementary algebra or intermediate algebra. Okay, intermediate algebra and and the elementary algebra or beginning algebra, they have lots of overlap, especially on the factoring part. And you need to, to gain more understanding, you want to do those, you want to take a look at those. Okay, take a look at those. I will do the best I can to explain to you, okay, to explain to you. Now, when you are given from negative pi over 2 to pi over 2, basically it meant the horizontal span over here. Okay, negative pi over 2 to pi over 2. So it's not going to be very difficult for us to realize that this point, this heart here, okay, letter C, the x coordinate is pi over 2. So this point is, let me write it down for you. This heart at the C, okay, is negative pi over 2, comma, because it's sitting on x-axis, the y coordinate is 0. Okay, and this heart over here is pi over 2, comma, 0. Because it sits on the x-axis. Now, let's look at the lines. Let's look at the lines, right? Did you guys write it down? Let's look at the line. Look at this line in particular, the line D, right? Since we have identified this point, the information is here, right? The information is given to you here. And you may notice that negative pi over 2 and pi over 2, these are the 2 points that cannot be in the domain. Cannot be in the domain. When k equals to 0, you get pi over 2. When k equals to -1, you get negative pi over 2. So these are the points that cannot be in the domain. That's why you see the broken line will never touch the curve, will never touch the curve. The curve will get infinitely close to the red. But now what is the question is, I was asking you to identify the line equation of this red, for example, right? You have 1, 2, 3, 4, 5, 6 to identify. They have some, you can see they have similarities. So let's first identify the line D, right? What is line D? If this point is pi over 2, 0, and that means on the same vertical line, what do they have in common? All these stars I drew here. What do all of these points have in common? All of these points have in common is their x coordinate is pi over 2. Y coordinate, I don't know. Okay, the next point is also pi over 2 is the x coordinate. And the y coordinate, I don't know. Okay. For all of these points, they have the same x coordinate. Y coordinate, this must be a negative, but who cares? So that's the feature of all the stars on this line. That's the common feature. What is that common feature? What is that common feature? They have the same x coordinates. They have the same x, right? Remember when you do x, you do line equations, you have y equals mx plus b, right? That form. But this is not in that form because y is free. Okay, on this vertical line, you can go as high as possible and you can go as low as possible. That means, now, what is the line equation? What is line equation? Okay, I'm going to repeat what I'm going to say and then write it down. You need to listen very carefully. A line equation is the description of common feature or features of all the points on the line. Okay, a line equation is a description of features or features of all the points on the line. Did you guys write it down? Write it down in the language we understand. A line equation is a description of common features of all the points on the line. A lot of you probably recognize this y equals mx plus b, right? You think you know line. But what does this mean? This is a common feature of all the points on the line if this is to describe a line. That line has what common features? They have the same slope. Okay, between any 2 points, they have the same slope. Okay, B, that's the y-intercept. That's a common feature. Okay, but this form is not fitting to describe the vertical line. Okay, these are the special cases because in this line, in this equation, y on this line, we have all the stars all over. On this line, the y coordinate can be any real number, which means y is a free variable, okay? Because the way you can imagine, the star can go as high as possible, as low as possible. Nothing can constrain it, no constraint. Therefore, that feature cannot be expressed by this line. Okay, for those of you who understand, who maybe know a little bit about the vertical line, if you still have residual memory about it, or what you learned before, in fact, the slope of this line is infinity. So you don't have that common feature of these lines. The slope is infinity, right? So what do we use to describe this line? We describe this line by the common feature of all the points on the line. So now I have just marked the common features. What is that common feature you think for that vertical line, which is covered by the stars? They all have the same x coordinates. Do you guys follow me? Don't they all have the same x coordinates? Pi over 2, pi over 2, pi over 2, pi over 2 forever. Doesn't matter how high it goes or how low it goes. The second coordinate, y coordinate, is free. How do we express free? It doesn't show up in the equation. It doesn't show up in the equation. Therefore, okay, therefore, this line equation is x equals to pi over 2. That's the line equation. It describes all the points have the same x coordinates. And then you say, what happened to y? Y is free. Y is at large. You follow me? So now, if you understand what I just talked about, can you give other points according to the domain we have there and give me the line equations for A, B, C, E, F? Can you do that? Can you draw a tiger out of a cat? Shall we do a breakout room?
I'm here, Professor. Is that x equals pi over 2, Professor?
Yes.
Oh, okay. I don't see the another line because it's overlapping on the black
This one?
line. Yes.
X equals pi over 2. Let me rewrite it. That star, that line that covered by the stars is x equals to pi over 2. Okay. If anything, you need to it's actually not important that you know this line equation in that general form if you don't understand this sentence. This sentence is worth you reading many times, many times, especially every time you see an example, right? This sentence is meant to be understood. It's meant to be understood because once you understand it, you can write it down in many different ways. Okay, what is a line equation, right? What is a line equation? A line equation is a description of common features of all the points on the line. Okay, that is at essence. You have to be able to speak that language to yourself. Are you going to be dealing with line equations? Absolutely, in calculus. Calculus 1, you're going to be dealing with line equations. We haven't spent much time on this course on line equations because I don't know if you guys know it, but now as I ask you the question to give me the line equations and you guys, you cannot do it or you're not sure how to do it, that means you need to review that part. Do I have time to review that part today? Not much. This is how much I'm going to spend time with you on it. There's a lot of materials like of similar nature you will have to pick up on your own, or when you're taking calculus, you will have to supplement that deficit. You have to supplement that deficit. Okay, because as much as we can, these 5 courses cannot be done in the details it requires in one semester. I believe these topics, it should not be too hard for you to study by yourself. But if you have any questions, then please do come back to me. Okay, do come back to me. By the way, at the end of the class today, I will have a special announcement. Okay, you don't get to, I only have so much time with you this semester. Okay, and it's up to you to make that effort, to make the grade, to make it into calculus and out with a good grade. You have a lot to do. All right, so without further ado, do you need a breakout rooms? So I'm going to set it up there anyway. Okay, so this part is reviewing the line equations. So from time to time, when I discover there's some issues, I will try to, cover that. But it cannot be as thorough as a course, elementary algebra course, to cover it.
So, Professor, basically you want each vertical line be identified the way you identified one of them, like x equals pi over 2. You want us identify the other lines? Like
yes,
x equals
I want you guys to identify the points, lowercase a, b, c, d, e, f, and identify the lines, the vertical lines, a, b, c, e, f.
So for D is x equals pi over 2, and we are going to copy same process for other ones.
Exactly. Okay.
Okay.
That's the point, that you go through the same process that I have set example for you, and to identify all the other points. Okay.
Sure.
And the other lines. Is that clear, everybody?
I see the breakout room. As soon as anybody goes there, I will jump into breakout room, Professor, if it is okay with you.
Yeah, thank you. I think
Yeah.
I think the students are hard at work. Okay, guys, we cannot spend time here forever. So let me just give you the answer, okay? This line is x equals negative pi over 2. And the point E is, I'm gonna close that room. Farouz, are you there? No, it looks like nobody went. Oh, Jacob's there. Okay. But anyway, I'm calling you guys back. Okay. So this point E is, that's 3 pi over 2. Comma 0. And the line equation, x equals to 3 pi over 2. 3 pi over 2. Okay. And this other one, this B point is a negative 3 pi over 2. Comma 0. And that line equation, that vertical line equation is x equals to negative 3 pi over 2. I'm sorry, Jacob and Farouz, and I call you guys back very quickly because we cannot stay here forever. Okay.
That was good, Professor. Jacob just was, answering the question real fast.
Oh, very good, very good. So you can see how to identify points, right? It's basically input output, right? So the vertical line where I have marked here, and I have marked all these points here, and then for A and for F, I leave it for you. Okay? So these are the features that you need to be able to identify. Okay? And if you notice that these points, negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, negative 5 pi over 2, positive 5 pi over 2, they are all included. Where are they included? They're included here, right? They're all included in this form. That's what this form is for. This form covers all of these points. It covers all of these points, all of these hearts where the red vertical line crosses. The red vertical line cross, right? That's how they're related. Do you guys see that connection? All right. So did you guys write them all down on the screen? Because I'm going to clean this all up and we're going to do truncation. Did you write them down? Did you write them down? Yes or no? Okay.
I need a little bit more time to finish writing. I'm almost done with it.
Okay. So you will see the connection between the domain of tangent, which the angle can be any real number but the odd number multiples of pi over 2, and you see all of these hearts sits on the points where the x coordinates are odd number multiples of pi over 2. Do you guys see that? And the vertical line are described, by x equals to odd number multiples of pi over 2. Do you guys see that connection? That's the connection. That's the connection. Okay. So now when we are doing truncation, what do? Wilbur was right. We leave the piece in the middle and we consider that's the simplest. So we keep this piece from negative pi over 2 to positive pi over 2, from negative pi over 2 to positive pi over 2, the range from negative infinity to positive infinity. What happened to the rest of the pieces? We just cross them out. Cross them out. And that consequence is the function right here. The consequence of crossing those pieces is that. But there's a lot of implication to it. There's a lot of implication to it. Okay, are you guys ready for me to clean up all of these? Okay. Farouz raised his hand.
Yes,
Oh.
Professor.
Yes.
Now we are ready to go after inverse function of tangent, because as you said before, the trigonometric functions are not one-to-one because periodic. By doing this, you prepare us to know about this tangent. The chosen one is going to have the inverse now. Is that correct?
Right. Well, we're getting there, but we're going to be doing tangent and the inverse function back and forth. Okay, we're going to still identify points. All right. So now I'm going to clean all of these up. Okay, truncation has taken place. So this piece, okay. So now let me clarify. I hope you guys understand. This guy is for that. Okay, just to make sure you write your notes properly. This is the entire tangent curve. Okay, the domain is x. The input angle can be any real number but odd number multiples of pi over 2. The range is from negative infinity to positive infinity. And after the truncation, okay, after the truncation, we have this function left. And this function, the graph, okay, is no longer the same. Okay, so I'm going to okay, so this is the piece that's left. After the truncation, that's what's left. Do you guys follow me? Between negative pi over 2 to pi over 2. So now on this new picture, okay, the truncated, the consequence of truncation, this function describing just one slice. And now in order to understand this slice, I want you guys to mark points. Okay, what I'm going to ask you to mark, I'm going to ask you to mark these 2 points. And you're also going to mark these 2 lines. Okay, this line, which is A, and that line, which you mark as B. Could you do that for me, please? This should take no time for you because we already did it. We already did it. But you understand, okay, this is only part of the tangent. This is only part of the tangent. Ah, oh no. Are you guys doing that? Okay. Actually, I'm going to change the color for this tangent curve just for contrast. Okay, for contrast, I make it a green. I make it a green curve. Now we know this piece, this curve has what? This curve has inverse. It's 1-to-1, right? It's an increasing function. It's an increasing function. Have you guys marked those? So what should be A?
It should be negative pi over 2.
I'm sorry?
It should be negative pi over 2.
That's incomplete answer.
Or x is equal to negative pi over 2.
That's right. You cannot miss that x equal to. Very good answer, but you have to give a complete answer. Because whether it's x equals to negative pi over 2 or y equals negative pi over 2 is a completely two different lines. Okay, as we're going to see down the road. Okay, so your perfect answer would be x equals to negative pi over 2. In order to give you all the credit, your professor has to see the perfect answer without anything missing. Okay, if your answer is just negative pi over 2, guess what? You are getting 0. Because we don't know what negative pi over 2 is just a number. But x equals to negative pi over 2 tells the reader that every point on this line has the common feature, which is the x coordinate equals to negative pi over 2. Do you guys hear the difference?
Yes.
Right? Meaning in mathematics, understand the meaning in mathematics is essential. It's essential. Okay? All right, so without further ado, so how about these 2 points? The 2 points at the heart. Have you marked them? When you mark the points, what you do? You have to have both numbers in place. Because this point is described by an ordered pair. The key words is ordered, right? If you don't have the proper order, even though you have the number, they're not going to be the same thing. For example, if the answer is 0, negative pi over 2, that describes an entirely different point, isn't it? You guys follow me? And this will be wrong, and that's right. Does everybody follow me? And this other point, of course, is pi over 2, comma 0. Okay? Now, okay? As Farouz just was looking forward to, right? This function, okay? Suppose I call this function g. Okay. G is 1 to 1. G is 1 to 1. Thus, it has a unique inverse. And we're going to call that inverse G of inverse. Okay, so before we get to the details, okay, just looking ahead, this function G is 1 to 1. Okay, this function G is 1 to 1. All right, so let me do this. Okay, so what is our G? This is our G. This is our G. And G is tangent X with a specified domain, right? So with that specified domain, okay, let me use A then. Okay, let me just use A then. It doesn't matter. Okay. A to emphasize the angle and the range. We should be very familiar with this by far, right? We've been just talking about these from the beginning of today's class. And G inverse exists, right? The inverse function exists and is called G inverse. That equals to whatever name. Okay, we're not gonna give it a name yet. But because these two functions are inverse to each other, we already know the domain and range for G inverse. Do you guys follow me? So domain, range. The domain for G inverse will be from negative infinity to positive infinity, and the range will be what? What will be the range? The range will be from negative pi over 2 to pi over 2, okay? So let me first write it this way. Do you guys follow me? Before the inverse function even acquires a name. So let's look further for the meaning of inverse. Okay, so let's look further for the meaning of inverse. The G function takes angle, produces what? What does it produce? What does it produce? It produces tangent ratio. And its inverse, what does it do? What does the inverse do? What does it do? Tangent ratio. The inverse function take the ratio, goes through the inverse function, G inverse, okay, produces angle. And what is the angle? You see, now the domain tells you the inverse function can take a ratio of any real number. It produces angle between negative pi over 2 to pi over 2. Do you guys see that? Do you guys see that? This is the part that's a little bit difficult for people to understand. That's why we're going to go through the process. Okay? So in the process of going from G to G inverse, we know it's just a simple swap of domain and range, and it also the swap of XY coordinates. Remember, when we try to find inverse of any function that exists, that has the inverse, we swap that XY, right? What is the implication of that? That implication is tremendous. It's tremendous. Okay, so now we're gonna see that implication playing out. Okay, so before we see that implication, Okay, so first, before we see the point, the swap and the stuff, right? So now we can give it a name if you want. Okay, it's arctangent or tangent inverse. So these two names are used interchangeably, but they mean the same thing. They mean the same domain, the same range. Okay, so in order to do that, I want to bring back what we did before to plot some points on G, and then we're going to see how they're being swapped, the XY swap and its implication, okay? So I'm going to introduce a table, okay? This table will be about G, okay? It will be about the G, okay? Wait, maybe I should do it this way. Oh, that's fine. That's fine. Actually, that's okay. Okay, so I'm going to give you some values for A, and you're going to produce the output for G. And these values I'm going to give you negative pi over 3. Maybe positive. Maybe let's do positive. For positive is easier for you to start. Okay, so pi over 4, pi over 6. Okay, then it's 0. And then it's pi over 6, negative pi over 6. Okay, negative pi over 4. And one more. Negative pi over 3. Okay, I want you guys to leave some space, leave an empty line here, and then leave an empty line at the bottom. Okay, leave an empty line at the bottom. So what do you need to do? What do I want you to do? Right? I'm gonna give you an example. Okay, understanding. Okay, that's recall another thing. Okay, I'm gonna bring back my unit circle. Recall. Okay, recall on this unit circle. On this unit circle, how is the cosine curve made? How is the cosine curve made? Put it over here. How is the cosine curve made? Okay, so let me just make a little adjustment so that so it looks nicer. How is this cosine? We made the cosine for the, I'm sorry, cosine, I'm saying cosine, the tangent, right? How the tangent curve made, right? Take an example, it's from A to D, right? So from A to D, so how is the A? For example, take A pi equals pi over 4, right? Pi over 4. And we're gonna measure from the standard position, counterclockwise, pi over 4. And there's this orange arc length, which is the same value as pi over 4. Okay, so this is pi over 4, right? Remember that story? So let me just quickly make some adjustment about these drawings. Okay, here. That's 1. That's a little too high. 10. You guys know what I'm about to review for you, yes? Making connections to things we've done before, okay? Making connections to things we've done before. All right. So now take a pi over, take a tangent pi over 4, for example. Okay, we know tangent pi over 4 equals to 1. What does that imply? What does that mean? Okay. So let me just, I'm trying to make some adjustments. So the one on the right on both directions are the same. Is that about the same? Okay, that's about the same. Okay, so what we did is that we're gonna measure pi over 4. We're gonna measure pi over 4. That's the terminal. So this angle is pi over 4. And that arc length is pi over 4. Okay, and this arc length is straightened up. Okay, to straighten up. Hold on. The arc length is straightened up. I need to make adjustment this way. Okay, because this one, I want to be the same as this one. Okay, so that arc length, okay, that arc length, as long as it is, that arc length will be measured over there. Okay, so this orange is the same as the arc length in length, and the ratio 1, we're using purple. Okay, that's the ratio. That's the ratio between the blue and red. Negative root 2 over 2 divided by 1 over root 2. Okay, so that's 1. So that's pi over 4. So this is pi over 4. This orange pi over 4. And that's the ratio of 1. Do you guys understand that? Yeah? With that being reviewed, okay? If you want to see more, go back to watch the other recordings, okay? Watch the recording before this, okay? With that being reviewed, I'm gonna clean this up. So you are going to do all of these numbers. For example, for tangent pi over 4, which I just did, right? Equals to 1. How do I get the 1? How do I get the 1? I take the blue number divided by the red number. Okay, and so that point is angle to ratio. And that ratio, of course, is the blue divided by red. So does everybody know what to do? So this point is pi over 4 input, which is angle. The ratio is 1. So what you guys are going to do? You guys are going to do for all of these points, from pi over 3 all the way up to negative pi over 3. Do you guys know what to do? Or do you want me to do another example for you? Yes or no? Okay, go for it. Okay, and then we're going to plot the points. Okay, we're going to plot the points. So now I'm going to plot the point where I just did. You guys do the rest of the point. Did you get the table? Did you guys get the table? Do we need a breakout rooms? So let's set up the breakout rooms. Okay, self-select. Okay, so I'm going to do the example. Okay, I'm going to put that point on the graph. Okay, you're going to work out this table. You're going to work out this table. Farouz, did you get that? Okay, you guys, you choose to stay with me, which is great. I'm just going to, I'm just a little, it's just one step behind you. Okay, so we're gonna put the points, but we're gonna do the calculation. right, guys, welcome back. It has passed the time. I wish to give you guys some break, but let us put all the points on the graph. Okay, let's put all the points on the graph. Okay. So I'm going to put all the points on the graph. And please, you do the same. Okay, so we have all the points here. And when we come back, I'm gonna take, I'm not gonna give you 10 minutes break. I'm gonna give you just 5 minutes break. Come back at 9:20, okay? Come back at 9:20. Meanwhile, if you don't wanna take that break, you can start marking the points on the graph, okay? And then we're gonna do the inverse. I hope we're going to complete tangent today, so we must get this done. So I'm not going to give you 10 minutes break, just 5 minutes, okay? So back at 9:20. Okay, I'll see you guys soon. See you soon. Okay, guys, come back. Did you guys finish plotting the points? I want you guys to put the points on the graph and also mark them properly. You see the way I marked it, okay? This point I mark is pi over 4, 1. It's not in the color tone I wished, but I'm going to mark the rest of the point in the color tone I want, okay? So for example, I'm going to mark pi over 4, 1 again with the color tone of my choice. And I will explain to you why is that, okay? To enhance our understanding. Okay, so pi over 4, I'm going to use the orange. We've been using orange color for a specific reason. Can anybody refresh us about that?
Because it's the arc lens.
That's right. That's right. Right. And the next one. Thank you, Jacob. And so you can see we use that orange color consistently across sine, cosine, tangent, tangent, right? Arc, sine, arc, cosine. So that's the reason we try to use this color. And the purple color is a ratio between the blue and the red. Okay, dividing the blue by red, right? That's we get the purple. And this point is pi over 3 in orange. Okay, and the purple is √3. And next, this point, okay, the orange color is pi over 6. And the comma is √3 over 3. Oh, orange. I'm sorry, wrong color. Sorry. Okay. √3 over 3. Purple. The next one, this point. Okay, that's negative pi over 6. Okay, and the purple is negative √3 over 3. And this dot here, that color is negative pi over 4. So in the process, you can see this is after truncation, right? So what is the implication of this truncation does for us on the unit circle? That's something I want you to think about, right? You can see the angles of our choices between negative pi over 2 to pi over 2. As a result, do we have a non-flight zone? No flight zone? What would be the no flight zone? Oh. Let's do it again.
No flight zone on the unit circle, Professor?
Yes. What is a no-fly zone? I want you guys to think about it. Yeah? What is it? Okay. Just give me a second. I'll be right back. Okay, I want you guys to think about that question. I want you guys to mark these points. Mark these points on your notes. You should have a paper, pencil, notes. Taking a picture is helpful, but it's not good enough. I insist on you write it down using your paper, pencil for yourself, please. If you look at that unit circle from what we did, so whenever you handle, when you handle these, you handle these points, right? To measure pi over 2 from negative pi over 2 to pi over 2 to measure those angles. What are the quadrants you never fly over? What are the quadrants you never fly over? Yeah? What would that be? Anybody? Remember for arc sine, arc cosine, we all have a no-fly zone, right? We all have a no-fly zone. Which one would this be? Well, if we only measure from either from negative pi over 2, this is how you measure to up to negative pi over 2. You can measure all these angles. No more pi over 2, no more. So that will make what? Quadrant 2 and quadrant 3, no fly zone. When ArcTangent is introduced. When ArcTangent is introduced. Do you guys see that how they are connected, right? How they are connected and how they're related. Yes, do you guys see that? That's what I want you to see. I want you to see these connections. Okay, so without further ado, we have these points and we identify the no-fly zones. Next, it's time to introduce our ArcTangent. Okay, so let's see our ArcTangent. Okay, so let's first start from the table. There's one more thing we need to cover, right? We need to review actually, okay? We know that negative pi over 2 is undefined, right? Negative pi over 2 is undefined. Pi over 2 is undefined. Let's do the positive, right? Since I do this on positive side. So pi over 2 is undefined. Therefore, we want to see what happens if A approaches pi over 2. Okay, if the angle approaches pi over 2, right? If the angle is approaching pi over 2, I don't like this color. I like the orange color, okay? When when the angles approaching negative, approaching pi over 2 from smaller than pi over 2, right? Because this point is pi over 2, right? This point is pi over 2, yeah? We identify those. What happened to the output? The output, you can see, can go as high as possible. We did those exercises in previous sections. So here, I'm not going to go in that details, right? So when you can see when the angles approaching pi over 2, getting infinitely close to pi over 2, but never touched it. The ratio, the orange ratio, okay, which is the tangent of A approaches positive infinity. Approaches positive infinity. So this is on this end. You guys see that? Now, how about this side? How about this side? This side would be as the angles approaching negative pi over 2. Remember, we marked this point? That's negative pi over 2. When we approach negative pi over 2, and the ratio is going to approach negative infinity, okay? But we're approaching pi over 2 here, okay? I'm missing something important, okay? We're approaching pi over 2 from smaller than pi over 2. So we put a little negative sign on the shoulder. 175%. The software is not consistent in doing that. Okay. Let me do it again. Do you guys follow me? When the angle approaches pi over 2 from smaller than pi over 2, the ratio approaches, you can see the picture tell us the ratio approaches as large number as possible. So that's being described by this piece, okay? Calculus, this is a calculus. So calculus will quote this. In your calculus class, your teacher probably just use it directly, okay? There's not explanations like what I have here, at least not in that detail, all right? So now let's look at the other direction. Let's look at the other direction. As the angles approaches negative pi over 2 from larger than pi over 2, because here, this is negative pi over 2. So the arrow direction is going closer and closer to negative pi over 2, but larger than negative pi over 2. So how do we describe that? Right, so I'm going to put this just temporarily to be here. Okay, so as A approaches, okay, these notations, you have to follow me to understand these notations, okay? When I was teaching calculus class, sometimes it takes half semester for some student to understand the notation. By that time, they have lost the 10, 20 points already, okay? So we are approaching negative pi over 2 from larger than negative pi over 2. From larger, okay? Because this is from right to left. Remember number line, guys? Number line? Left is smaller, right is larger, yes? So when you're coming from right to left, you're approaching that from larger. When you're coming from right, when you're coming right to left, you're coming from larger. When you approaching in this direction, right? So let me write it down. I just find these softwares that are not terribly ready for my need. Okay, so in this direction, it's A approaching pi over 2 from smaller than pi over 2. This is a pi over 2. This point is pi over 2. Okay. This piece, this dot is pi over 2. Okay, that's pi over 2. Whoops. Pi over 2. You guys follow me? So we're coming from left. So we're coming from the smaller side. Okay, we're coming from the smaller side. Are you guys with me? On the other direction, at this point, is a negative pi over 2. So you're approaching negative pi over 2 from larger than negative pi over 2. So that's how you have this positive sign on the shoulder, okay? Because I think this notation may be particularly confusing for you. Maybe is that because you have a negative number, but you're approaching from larger than size. You follow me? So each symbol in their position, they mean specific things. They mean specific things. That's the nature of mathematical notation. That's the nature of a mathematical notation. If you don't understand the notation, you're screwed. You're screwed. Okay? All right, so with that said and done, what happens when the angle approaches negative pi over 2 from larger than negative pi over 2? And the consequence is that the ratio, the blue divided by red is approaching, what does it approach to? It approaches to negative infinity. It approaches to negative infinity, okay? So that's what we want to put in there, okay? So let's move forward. So let's look at what happens if we identify that inverse function, okay? Still comply with all the notations we know, okay? All the properties about inverse function to each other, right? By this time, we had dealt with inverse functions a lot, right? So we're gonna start with this table. I want you to see the action. I want you guys to see the action. Hold on. I want you guys to see the action of okay. Okay, so this table is about G, okay? So I'm going to create a table which is G inverse. So this is changed to inverse, right? This changed to the inverse. And now it's ratio to what? Ratio to angle. Ratio to angle. So this function is G inverse. The inverse function is ratio to angle, okay? Ratio to angle. Of course, the angle has to be between negative pi over 2 to pi over 2. And in this process, you can see that ratio to angle. Now, this would need to change to what? To ratio. So where would be the output go to? The output will go to, these inputs that for G now are going to be for the outputs. Whoops. Okay, it's going to be for the outputs. Wait. This. Jesus. It doesn't do it for me, huh? 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. Let's do it again. Jesus Christ. sorry about that. The input, the former input becomes the now output, right? You see, it used to be the input, right? Now it becomes output. You follow me? And these two pieces, okay, I'm not going to handle for now. Similar, okay, similar. So now the input output swap. We're going to swap the input output. So now all of these points will swap pi over 3. So let's do it one by one. Do you guys follow me? And you do it too. That's the swap in action. This is a dynamic process. That's the consequence of swapping x, y. Okay, 0 swap with 0 doesn't make any difference. But it's a swapping between, there's still the meaning swap, right? Even though sometimes the number has changed spot, but their meaning also come with it, Okay, so let's completely swap. Let's completely swap. Okay, you can see the implication of just swapping x and y. And also, of course, the domain range swapped, right? Domain and range swapped. We already saw that earlier on. But the point-wise, every point swapped. The former output become the input. So all of these are inputs, okay? Root 3 is a new input. 1 is a new input. Root 3 over 3 is the new input for the inverse function. 0, that output becomes that ratio 0. This is a ratio 0. This is a radian 0, angle 0. Do you guys follow me? Even though they both are 0, they have different meanings. Do you get it? And now this is a negative root 3 over 3. That was output, now becomes input. Negative 1, that was output, now is input. Root 3, it was output at G and input for G inverse. Does everybody follow me?
Mhm.
This is the implication of X swapping with Y. Domain have swapped. We have swapped the domain. Now we're swapping points. Okay. Next, right? So with all these swap, what is the new function we have here? Of course, it's not tangent anymore, right? It's arctangent of X. So the input now is ratio turn into angle. And these are the ratios, and these are the angles. Do you guys understand? And the output reflected that swap, right? The swap. You see the swap. Do you see that swap?
Mhm.
1 to 1. This is the true meaning of 1 to 1. This is the true meaning of 1 to 1 in action. Okay, so let's introduce the function. So arctan of root 3. So write it down with me exactly. Okay, so arctan of root 3 equals pi over 3. I want you guys to write this down, copy word for word as I do here, please. Arctan of 1 is equals to pi over 4. Arctan of root 3 over 3 is equals to pi over 6. This 0 is ratio. This ratio means angle. Do you guys follow me? They're both zeros. 0 and 0 may have different meanings. Okay, arctan, so depend on where they are. Okay, depend on their position. And over here, arctan of negative root 3 over 3, that's equals to negative pi over 6. And arctan of pi over 4, sorry, pi over, I'm sorry, root 2, root negative 1, I'm sorry, what I'm doing here. Okay. Arctan of negative root 3. I'm sorry, I have a typo there. Negative root 3 there is negative pi over 3. Okay, check for me for Ruth. And I tend to miss something here and there. Does everybody follow me? This is the inverse. So inverse meaning that input output swap places. Okay, you saw that in action. Now, okay, related to your calculus, How about this piece? Input becomes output, output becomes input, right? So this is about the input, this is about the output, this is about the input. 175%. Okay, so you can see all the signs. So when input approaches negative pi over 2 from smaller than, when input approaching pi over 2 from smaller than pi over 2, and tangent approaches, the output approaches infinity. Because the swap, right? When ratio, right? Angle ratio. This is angle, this is ratio. Now ratio becomes the input. So when ratio become input, X represent ratio. When ratio approaches positive infinity, the angle, which is the output now, right? Arctan of X, that's the angle which is approaching pi over 2 from smaller than pi over 2. You see that swap? Once again, input angle, output ratio. When this happens, input ratio, output, now the output is input. So when X is approaching negative infinity, okay, the angle would approach negative pi over 2 from larger than pi over 2. That's the process, okay? So now let's plot the points. Okay? To plot the points, okay? To plot the points, you just have to plot, just swap all these points, okay? So what I'm going to show you is that I'm going to set up a rectangular system. I'm going to graph. Wait. Okay. So we're graphing all of these points. Okay, swapped. All right, you ready? You do yours, I do mine. And we're gonna use red dots. I'm gonna use red dots. One more. These dots, okay, I need to make some adjustment. Look at these dots. Okay, look at these dots. These are the dots, right? This guy goes there. Give me, I try to speed it up a little bit. Okay, so these are the positive points, and the negative points are reflected accordingly. Okay, so now it's time for us to introduce the arctangent curve. Arctangent curve, red. Arctangent curve. Okay, this is the arctangent curve. What happened to those asymptotes, the vertical asymptotes in the tangent? Well, now they're going to become horizontal. They're now horizontal. Okay, broken line. Okay, so how about these lines? How about these lines, right? The one on the top, the one on the top is y equals to pi over 2. The one in the bottom is y equals to negative pi over 2. That's the consequence of swapping xy, swapping xy. What if we put these two both curves together? What if we put both curves together? What if we put the both curves together? The existing software, if I put them together, it creates a mess. It creates a mess. Okay, so I did something to reproduce a picture. Okay, so I'm going to bring that picture which I created from my I created before class. I just need to bring them back to show you. Okay, and meanwhile, if you have any questions, then please don't hesitate to ask me. Okay, so the curve I created. Okay, so now we have both curves, right? We have both curves. We have the arcsine, I'm sorry, the tangent and the arctangent, right? So we have these two. Okay, we have these two. Okay, we have these two. And with these two, I'm gonna bring you guys to the very top. And if we bring both pictures together, if we bring both pictures together, okay, if we bring both pictures together, in one picture, this is what you get. Okay, this is what we get. The green is the tangent between negative pi over 2 to pi over 2. The red is the arctangent. The red is arctangent. Okay. So I'm going to actually have to speed up a little bit, and we cannot spend too much time here if I want to finish what we want to do this week. Next, we want to bring these two functions together. We want to bring these two functions together, right? Function and its inverse, right? These two functions. These two functions, their domain range as specified. We know their inverse function to each other. And we also know another very interesting properties. We also know another very interesting properties, okay, which is this related to which is for any pair of functions that are inverse to each other. Okay, and this equals to x where for X in the domain of F inverse. Remember this property we have used over and over again? And the other one is F of inverse of F of X equals to X. That's the composition for X is in the domain of F. So this piece also works for the G as we have studied over here, okay? As we have studied over here, right? We got this curve, we get that curve. Let's apply this property to G. Let's apply this property to G. If we apply this property to G, what do we get? This will be G, and that's going to be G, and that's going to be G, and that's going to be G, right? Let me make it larger. G. Now, with that said and done, what is G? G is tangent with that specific domain and range, right? G is that function with the specified domain and range. So G is tan, G inverse is arctan. And X belongs to the domain of F of G inverse, okay? G inverse. And what's the domain of G inverse? Negative infinity to positive infinity. There. G inverse is arctan, and G is tan. Okay, these two parentheses actually is not necessary anymore. And the domain of F, and of course this is domain of G. G refer to that one, and the domain of G is between negative pi over 2 to pi over 2. This is the third line, okay? This is the third line. In the first table in trig 7a. In trig 7a. Do you guys follow me? So all of these process, I have explained this to you. I hope you guys understand. Is so that you can use them properly. You can use them properly, okay? One more thing before we get to the exercise in that, okay? In general, when we talk about G, when we talk about tangent, which tangent do we refer to? Which tangent do we refer to? When we talk about tangent, we always refer to that tangent with domain. Can be any real number, but odd number multiples of pi over 2. Okay, and the range is always from negative infinity to positive infinity. That's what we are talking about. Okay, so in this property we just addressed, which property am I talking about? In this property we are talking about, in this tangent with otherwise specified. That's how we do the otherwise specified. Okay, so with this understanding, let's touch a couple questions in, let's touch a couple questions in trig 7a. Okay, so now we can do the tangent. Okay, now we can do the tangent. Cotangent, unfortunately, I will not have time to do it for you, and they will not be tested. But you need to do the homework, Okay, in your calculus class, there's definitely cotangent. I will not be testing you, but I will give you some information next week about it, okay, about cotangent and arctangent, but I won't be testing you. All right, so for example, number 27. Okay, number 27. If you look at the first property, actually, the first property basically tells you once you have tangent, arctangent, because arctangent has a domain of all real numbers, so this condition actually is not necessary. Okay, it's for any real number, it's true. Okay, so for example, on tangent, 27, tangent and arctan of 3/2, this is not a special angle. What would that be equal to? According to this property, it just equals to 3/2. Okay, because 3/2 is one of the real numbers. And this property works for all real numbers, so it works here. Okay, but the other one is a conditional. The other one is a conditional, okay? So let's look at, say, number 33, right? Number 33. Number 33, we have arctan and tan of 2 pi over 3. 2 pi over 3. How do we work that? How do we work that? Apparently, that property does not apply. Right? That property does not apply. Does not apply. And then what? And then what? We have to do it from inside out. We have to do it from inside out because this tangent is defined in the domain, which is any real number but the odd number multiples of pi over 2. 2 pi over 3 is not in this interval. So that property does not apply. It doesn't mean it's undefined. It is well defined because 2 pi over 3 is not any one of those odd number multiples of pi over 2. So we're going to do it from inside out. Okay, so what is tangent 2 pi over 3? You can use a unit circle and you can use, whatever tool you have at your disposal. Okay, and of course, the most convenient one is, it's this guy. But it's up to you. You can use definition as well. Okay, you can use definition as well. So in the inside the parentheses, it's a matter of ARD. ARD, right? ARD, right? The definition is tangent. So you see the blue number, you see the red number, you divide these two, what do you get? The blue divided by red, we just did it, right? So you get a negative √3. Arctangent of negative √3 is giving you an angle. So we should expect an angle. But where should this angle be? This angle should be in the range of arctangent. What is the range of arctangent? What's the range of arctangent? Between negative pi over 2 to pi over 2. Okay, so all of these are the different forms of writing them. For sure, I will be testing you guys about these things, okay? So between negative pi over 2 to pi over 2. So your answer is going to be between negative pi over 2 to pi over 2. So now you look for the ratio, which will give us what? Will give us this combination. Okay, this ratio. Where else do we see that ratio? Where else do you see that ratio? Root 3 over 2 divided by negative half equals negative root 3. This piece also give you that ratio, right? Yes? Which angle should be the answer? This gives
Negative
you two.
pi over 3.
That's right. You have another one. Right? And of course, you have many more if you go around and round, right? But because the nature of arctangent and its range requirement, and this piece falls on the no flight zone. Therefore, your answer has to be negative pi over 3. That's the meaning of no fly zone. You cannot fly over. You cannot go over. You cannot just do over and over, because that's you fly over. You fly over. You just cannot get there when arctangent is talked about. Okay. So that's all about tangent tangent composition. I said I have a special announcement for you. First thing is that next week is going to be the midterm exam. So next week you will not having quiz, but you are going to have the midterm exam available to you on Friday. Okay, so you have 3 days for that midterm exam. Friday, Saturday, Sunday. Okay, Friday, Saturday, Sunday. What am I going to test you on? I'm going to be testing you on everything we cover from the beginning of the semester until Thursday next week. So you have Friday, Saturday, Sunday. Okay, 3 days, 3 attempts. Okay, so let me give you the tip as how to do well on that quiz. You just have to watch these videos over and over again. Okay, watch these videos, watch the recordings over and over again. That's to get you do better and practice. Okay, that's the tip. Number 2, after week number 8, there will be the following week is week number 9. On Monday, Tuesday, I will be teaching. Okay, that's 25th and 26th of October. 25th and 26th October. Tentatively, I will be on medical leave till the end of the semester. Okay, I'll be on medical leave till the end of semester. Very regretfully that I will not be with you guys until the end of the semester. Okay, I have my recordings for all of what I've done and the spring semester. So if you like my teaching style, I hope that the substitute will keep those. Okay, I will certainly make them available. So the reason why I make these announcements to you, because if you want to download anything or have a set, they're all actually on YouTube if you know how to find them. Okay, if you know how to find them. So that way, if you want to, as using my teaching as a reference, you can. But most likely, I will not be returning because I'm going to be undergoing a major surgery for my unfortunate cancer treatment. All right. So that's my heads up for you, that I will no longer be available on the 27th. So make the best use of me prior to that. And I would encourage you guys to continue to work hard with or without me around. And I trust you guys will be doing that. And I wish you guys the best of luck. But before I leave, you can still make the best use of me. And I feel very responsible for you guys because I have you from the beginning of the semester. My medical condition, prevent me from staying with you guys till the end. But I trust the department will find I'm sure the next teacher will be just qualified and well-trained as you guys deserve. And I'm sure that you guys will be in good hands. But meanwhile, as teaching styles goes and how we go about to approach different things, and everybody may be doing things differently, I will be talking to the sub about what I have been doing and how I do it. But in no way I will tell him or her what to do. So you need to understand that. So as students, you guys want to be you need to advocate for yourself. If you don't understand anything, you just have to insist to get what you need, okay? And the bottom line is understanding the material and be successful in the next courses. So these are the two announcements that I wish to let you know. And if you have any questions, feel free to reach out to me. So I'll be here until the 26th. Okay, I'll be available until 26th. So, and on the 27th, I'll be, in my surgeries and stuff. Okay.
Sorry to hear that, Professor.
I'll be fine. I'll be fine. Yeah.
And so have a nice weekend for this class.
Thank you.
You're welcome.
Thank you, everyone.
I have a couple questions.
Yes.
So for the first question is how much time do we have for the midterm?
Each sitting, could I answer that question next week?
That would be fine. It's okay.
Yeah, I will definitely let you know before, but right now I haven't finished preparing for that midterm. I'm still working on it, but before the midterm, you would know. Because you have 3 sittings. Each sitting, how much time? I haven't quite decided. Of course, at least 1 hour, and but I will be giving you a definitive answer next week. Thank you, and sorry for never talking in that. Thank you for your comments. No worries, no worries. As long as you're learning, and I'm glad. I'm glad, right? I'm here to help, and I enjoy you guys, right? And I have learned much from you. I'll see you guys on Monday. So we still have we still have time together.
Wait,
Okay?
Ms. Wang, I have another question. Sorry.
No worries, no worries.
So you said we have until 5 to determine, is the midterm in like 3 parts, or is it like 1 part in whole? It's 1 part, right?
Yeah, the midterm is like a giant part of one quiz. It's just that you have more questions. Yeah.
So it's due on Sunday, right?
It's due on Sunday night.
Okay. You know me, actually, it's okay. It's okay. Thank you so much, Professor. I'll probably ask more questions on Monday. So
yeah, please do.
Thank you so much, and I'll see you either in office hours or on Monday.
Okay, I'll see you Monday. Will the class be asynchronous after October 27th, or there will be a new teacher during live lectures? That's something I cannot tell right now because I don't know how the department definitely can find a substitute, but as far as what the department will consider, right? I certainly hope there will be, but it's not as you can see from the catalog, a lot of teachers, they don't do asynchronous, they don't do synchronous, they do asynchronous. So it's up to the dean to decide whether whether they're going to continue my live lecture style or they go back, they go to asynchronous. So that's not up to me.
Professor, can I ask a question?
Sure.
I had a question about quiz 15 and last week, and I know there was a misconfusion and you took it down, but I was checking yesterday in the quizzes, and there's two quizzes. One is quiz 15 that was apparently due last week, and one is I think you put on yesterday or the day before, and there's two quizzes named quiz 15, and but
Oh, where do you see that? Where do you see that? Because I meant to take it down.
yeah, for me, because you said don't do it on Canvas, I think, and so I didn't do it. Now it says missing. So I
Where
wanted
do
to
you see it? Where do you see it? Tell me, because I meant to.
yeah, so for me it shows it on Canvas, and when I check my grades to see and then I go down, it says quiz 15. The one that was due October 10th is missing, and there's another one it's due October 17th, but this is for this week.
Right now you have quiz number 15 available to you, but that's
Okay.
not the same 15 last week. I just removed that 15 entirely.
Okay. So that one doesn't. So it's okay that it's missing, or
Yeah. So
Okay.
you mean the one last week?
yeah, the one last week. Yeah.
Yeah. So don't forget about that. I think I need to delete that somewhere from another place. I think
Okay.
that's what I need to do. So I hope you're not confused. So
Okay.
these
Thank you so
two.
much. Yeah.
I'm
Thank you
sorry
for
about that
the-
confusion.
Yeah,
So
it's okay.
15, yeah, it's just 15 and 16 that show up in module,
Yeah. Okay. I'll do. Yeah. Those are for this week. Got it.
right? And
Thank
the
you so
other
much, Professor.
15, let me investigate. Maybe there's some technical issues need to be resolved, but it's not going to affect your grading anyway. Okay,
Thank you so much.
but thank
Yeah, I
you
just
for
wanted to
bringing
get
that up.
cleared.
Yeah, thank you
Have
for
a great
letting
day.
me know. Thank you for letting me know. So yeah, I'm going to see if I can resolve that technical issues. Okay, maybe this is why. Maybe that's why. I need to delete that. I think this probably should do. Okay. Let me know next week. Any other questions?